Okay, so why organic chemistry in anatomy and physiology? For test purposes and quiz questions, if you hear me say anything about carbon chemistry, it's the same thing as organic chemistry. So organic chemistry is the chemistry that deals with carbon. Why is that important? Because all life that we know is based off of carbon. Okay. I think probably there's some theoretical biologists out there that might say that silicon or like sand based could also be but for the most part, all we know is carbon. The majority of the stuff that we're going to talk about in here is going to be either hydrocarbons, which are basically carbon and hydrogen compounds put together, or they're going to be doing something with sugar. Okay. And I'm going to have to take quite a bit of the functional group stuff out, which is unfortunate because that's kind of the coolest part. We will talk a little bit about some like alcohol and some ketones and things like that. You'll hear them and people use them incorrectly a lot. They'll talk about like carboxylic acids in the form of like lactic acid, and maybe somebody's gone on like a keto diet. You ever anybody gone on a keto diet where they just eat just meat? And I'll try to explain like why that's actually not a good thing to go into ketosis. Okay. Okay. Everybody's seen that equation, right? Cell resp. My guess is, though, you've never been explained what is really going on. Like, for example, does anybody know how you end up getting the 6 CO2s? Like, where does that come from? Like, what process makes the 6 CO2s? Any ideas? It comes from what's called the Krebs cycle or the citric acid cycle. Have you ever heard of those? One of those two things? Very good. I got a couple nods. Okay, we're going to be after Christmas, after break, we'll be talking about those in depth. All right. What about the ATP? Any idea where the ATP energy comes from? Ultimately, you are correct. It does come from the sun. But in this equation, what am I talking about? What process of cell respiration does the majority of the ATP come from? This should be kind of biology review, but I don't know if you guys remember or not. It's called the electron transport chain, the ETC. If you ever studied that before or not. So we have, and then the water also is the product of the Krebs cycle and of the ETC. Okay, so we have these two processes over here and another one called glycolysis, which gives us a little bit of ATP, which that arrow has all three of them. And there's several enzymatic reactions that occur just in that arrow. That arrow actually represents probably 20 some reactions, believe it or not. But to simplify it, they just show an arrow. But in reality, if I was to show you just a diagram, I'll just show you one. So this over here, oops, one enzymatic reaction, 2, 3, 4, 5, 6, 7, 8. There's 9 enzymatic reactions just in the Krebs cycle. Okay. There's another one just outside of it. It's called the preparatory stage. So there's 10 enzymatic reactions in just 1.5 kind of stages. This doesn't even talk about glycolysis. Glycolysis is splitting the sugar up so we can get to pyruvate. Okay. And then this, again, this isn't even mentioning the electron transport chain. So when we're dealing with all of this, it is chemistry. All right. So that's why I'm going to show you some basic organic chemistry and how all of these carbons, these 6 carbons, get rearranged, and they're here. They don't just magically appear. These 6 carbons that are here are going to transfer to 6 carbons, and hopefully you understand that's what that 6 does. That 6 is telling you that there's 6 carbon dioxides, which means that there's 6 carbons, which came from here. There's 12 hydrogens here. There's 12 hydrogens here. That's where those came from sugar. And then there's 12 plus 6. There's 18 oxygens. 6 came from here. 6 came from here. 12 and 6 is 18. So the molecules and the atoms actually are just kind of being rearranged. They're not like magically appearing. They're actually just being rearranged. How are they being rearranged? They're being rearranged by enzymatic reactions. Okay? And if you remember from biology days, enzymatic reactions are just there to basically speed the reaction up, to lower what's called the activation energy, which we'll talk about later. But it makes the sugar would naturally just break down. It would, but it might just take forever. You would end up not being able to get the energy that you needed from it just to happen. If you just let it to chance, it's not going to happen fast enough. So what you do is you add enzymes. And those protein enzymes speed this reaction up so you end up getting the ATP. The ATP is what you're going to use for all of your metabolism. All right, so let's talk about why carbon is so special. Okay, carbon is special because it has what's called 4 valence electrons. And hopefully you remember this from chemistry. And I'll draw this out for you here in a little bit. But the valence electrons are going to be the ones that can leave the shell, the outer shell of the atom, or can be added to complete an outer shell. Anybody know the magic number when it comes to chemistry of outer shells? What? 8. 8's the magic number. Now, this is probably wrong, and I'm not a chemistry teacher. I'm just playing one today. But I like to think of the electrons kind of as like planets, and the further you get away from the sun, the further the rotation is, right? And the less like pull they have, and so they can be stripped off easier, right? It would be easier to pull, if like we had a satellite that was orbiting Earth, it would be easier if the satellite was 100 million miles from Earth rather than 1,000,000 miles, right? Okay. So if you have outer shell electrons, those are easier to manipulate and change, rip off, get rid of, add to than it is if they're closer in. So the valence electrons are the outer shell electrons. Carbon has this really, really unique ability to bond to itself. Okay. And so I'll come back to this slide, but let me show you kind of the cool stuff about carbon. And remember, if we're talking about carbon, we're talking about organic chemistry. So carbon chemistry is based on the fact that carbon has these 4 valence electrons, okay? And it needs 8, all right? So what it can do is easily form what are called single, double, or triple covalent bonds, okay? If it's a single bond, if it's a single covalent bond, it's going to share 2 electrons. If it's a double, it shares 4, and if it's a triple, it's going to share 6 electrons. All right? And the way that you designate this, is everybody okay with covalent? I had to explain it the first hour, but do you guys know the difference between a covalent bond and an ionic bond? Please ask if you don't. It's okay. I can do it really, really fast. Need a refresher real quick? Yeah, I can. Yeah. Okay. So, this is kind of a side note here just to talk about, but we're not going to deal, you guys in Chem 1, you guys, this is what you deal with. It's all ionic. You don't deal with carbon chemistry at all. Okay. You do a little bit of covalent bonding, but for the most part, all you're doing is rearranging ionic compounds. Okay. Ionic compounds, they don't share. They cause what are called ions, cations. So you take a cation, which is like sodium, is a positive ion, and you add an anion, which is a negative ion, which means it wants to gain electrons, and you add them together to form a more stable compound. So the sodium, okay, is going to give up an electron to chlorine. Do you guys remember that from Lewis structures? You do this sort of thing. You have an electron here, and chlorine's got, and it goes whoop, like that. Yeah. All right. So that's not what we're doing. What we're doing is we're going to take in a covalent compound, and there's not going to be necessarily a complete give or a complete take. Sometimes it's going to be an equal sharing. Sometimes it's going to be slightly unequal. It's called a polar bond, which we'll get into later, and a non-polar bond. But for the most part, the electrons are shared, and the little e with a negative means electron. So if we look at, like, let's say a single bond between carbon, and I'll do these in different colors for you, so maybe it'll help. If you have, oh, that's good, Stubbs. Pick purple. You can really tell the difference there. Oh, we go with red. Oh, yeah. Well, that's just making the biggest difference in the world. All right. So instead of drawing all these dots, okay, don't draw dots anymore. Okay. Draw lines. All right. The line is going to represent a shared pair of electrons. Okay. So, like, if we had a carbon here and a carbon here, and it's got one electron to share here and one electron here. Okay. The way that you would just draw this is like that. So the little line represents two electrons. So this would be a single bond. If there's two shared pairs, I got ahead of myself there when I drew this first time, then I wouldn't draw 4 dots. I would just draw it as 2 lines. So this would be called a double bond. And of course, then if there's 3, and that's called a triple bond. And I'll explain what all that happens with carbon chemistry here real quick. Today, we're pretty much just going to talk about single bonds, and then Wednesday and Thursday, we'll hit double and triple. Okay, so let's go back to our slides here. So that's why carbon is important, because it has this ability to bond to itself in what's called many arrangements. You can have single bonds, you can have double bonds, you can have triple bonds. Okay? And if it's just hydrogen and just carbon, that leads to what are called hydrocarbons. And we depend upon hydrocarbons big time, like right now, literally. the results of our hydrocarbons is what's spitting out of these vents right now. We're burning natural gas. Okay. Natural gas is a makeup of two hydrocarbons, methane, okay, and ethane. Okay. I don't think we burn propane in the school. I'm pretty sure it's natural gas. So it'd be ethane and methane. So when you're talking about hydrocarbons, there's specific equations that you're going to use. It's much, much easier than drawing all the lines and all the dots and the Lewis structures and stuff. If you'll just memorize 3 formulas, this will help you out so much in college. Okay. I wish somebody had just explained this to me. It would have reduced hours of drawing out all this stuff. Okay. There's a need for it. I know that. Again, I'm not a chemistry teacher and I don't want to belittle this, but if you understand the formulas, you can get the chemical equations like that. Okay. Much, much quicker than having to draw it all out. All right. So let me show you some of these. Okay. When we're dealing with what's called saturated hydrocarbons, have you ever heard of that before? Sorry about my spelling. Just flipping letters like crazy today. Like a saturated fat. You ever heard of that before? Unsaturated. Whenever you hear saturated, it's full of hydrogens. So wherever there's a bond that's possible, it's full of a hydrogen. Okay? Now, if we're talking about the simplest hydrocarbon, it has to be methane. And I'll explain why it's called methane here in a second. It has all 4, remember there's 4 spots. There's 4 spots that carbon can bond. There's 1, 2, 3, 4. Each one of the hydrogens has an electron that it's going to share with one of the 4 carbons. So you end up getting this like arrangement of 4 spots or saturation around the carbon. It's fully saturated with hydrogens. Make sense? Now, when you start bonding together carbon, if it's fully saturated, that means that everything else besides the one bond that I'm going to like make red here is filled up with hydrogens. So even though, and this is where I think a lot of kids get confused. They're like, well, wait a minute. It's not saturated because there's this bond right here. Right. I get that. It's saturated when after the carbons bond, everything else is a hydrogen. So in this case, there's 1, 2, 3, 4, 5, 6 possible other spots that it could bond to. And all of those are filled up with hydrogens. So this is a saturated hydrocarbon. And we end up calling this, and we'll get to this later, ethane. Okay? Now, that means that you can use a formula. Rather than drawing all this crap out and taking forever, use this formula for all what are called alkanes, are saturated hydrocarbons, which means they're compounds that are only carbon and hydrogen. The formula is Cn, and N represents the number of atoms, H2N plus 2. So basically, all you've got to do is figure out how many carbons there are, multiply it times 2 and add 2. That will tell you the number of hydrogens for any saturated hydrocarbon, for anything that's all single bonds. So, I mean, if you want to take the time and do this, you go right ahead. If I got some crazy looking thing like this, I could put H's on all these, right? All the way down through here and add them all up. That's fine. Or I could just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I believe. I counted that right. C11, H, 11 times 2 is 22 plus 2, 24. It's much faster and much easier, I think. Questions on that? So if I had something that looked like this, something simple, what's the chemical equation for something with 3 carbons? Three times 2 is 6, plus 2 is 8. Okay, so C3H8 is the chemical formula for when you have 3 carbons. Okay, it's called propane. All right. Now, I don't like drawing out all these C's. I'd rather just draw a line. Whenever you have a line for line chemistry, this represents 2 carbons. And it also represents the 6 hydrogens. So if I had something like this thing, which if I want to, I can do this, which looks cute and all that kind of stuff. But to be honest with you, it's kind of a waste of time if I can just do that. This and this mean the same thing. Yeah? So this thing up here, one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Whenever there's a start and a stop, that's 1, 2, 3, 4, 5. So this would be 1, 2, 3, 4, 5, C5, H12. And you're like, how did you get the 12? 5 times 2 is 10 plus 2 is 12. Okay? Just use the equation. Where did I put the equation? Oh, it's right there. Okay? So let's have you guys try some. Please play along. I'm going to have a couple different things, different ways that you'll do it. I want you to try all of them. And a few of them may be kind of hard, but give it a try. Let's start out, and I'm going to give you the carbons. You tell me how many hydrogens. Hi. Talk to me. I've been a cross-country coach for 24 years. I'm okay with it. I've had a great group of kids who want to like that. That was much my clinical program. I do great things with Coach Hurst. What was your favorite part? Then just being around the kids, just watching them reach their goals and help them maintain how they achieve their goals. Very honored. just the relationships that are made over the years. Oh, wow. It just keeps driving through your goals no matter what they are. Yep, no problem. Okay, so let's do these three real quick. So again, we're going to use this formula. So hopefully this isn't too bad. Just multiply it times 2 and add 2. So this is going to be 14. This is going to be 26. It's going to be 34, if my math's right. I need to take my shoes off, start counting my toes. Okay, so that's the simple way to get the hydrogens, all right? There's a more difficult way if you're given the hydrogens, so let's try some of those. So now just rework it a little bit. It's not that hard of math. And if you know you've got to get to 8, okay, so you know it can't be 4. It has to be 3, because 3 times 2 is 6 plus 2 is 8. Did I lose anybody there? Okay, so this equation right here, this part right here, in order to get to 8, I got to kind of do some mental math here and think, all right, divide by 2 and subtract 2. Okay, I'm just doing the opposite. So I've kind of set it up so that I know that 2n plus 2 is equal to 8. Okay, so then if I subtract 2 from both sides, and then divide by 2, I know that n is 3. Same thing with here. 2n plus 2 equals 12. Subtract 2 from both sides. Divide by 2 on each side. N is equal to 5. Or just look at it and go, okay, if the way I do it is I look at it and go, what's half of 12? It's 6. And then I go 1 down lower. So it's 5. What's half of 50? 25. So it's 24. 24. Just go one number down lower. What's 24 times 2? 48. Plus 2? 50. Yep. Now, if you want to do the math, that's fine. But I think it's a lot easier just to divide it in half and then go down one less number. Okay? All right, so that's maybe a little bit more difficult. And we're not going to have a whole lot like that, so don't worry about that. Okay, so now, to me, this is maybe a little bit more important, is being able to figure out using line structures. I'll start out like this. Just tell me the chemical equation for that. And then I want you to draw that, and then the chemical formula for that. Okay, so I want the name. Oh, sorry, the equation here, the structure, an equation here. Chemical formula, is that what you guys call them probably? Chemical equation, chemical, yeah. So in this first one, all I did was just count 1, 2, 3, 4. There's 4 carbons. So just plug it into my equation. Okay. And I'll end up getting 4 times 2 is 8 plus 2 is 10. Double it and add 2. And then on this, and if you want to draw it out for right now, if you want to do this kind of thing, that's fine. I'll tell you whether or not I want the line structure or not. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3. And I get in the habit of go ahead and numbering them. It doesn't take you that long. Just do that because when we start adding on functional groups and naming these things, it can go this way or it can go that way. It doesn't matter. So that's why you should number them. And this last one, I just counted up to 8 times 2 and add 2, you get 18. Okay? Now, some of you are going to get this, like that. Some of you, it's going to take some videos that you're going to have to watch. All right? That's why I've got some posted for you. Go back to this. Now, when they aren't saturated, okay, when they aren't fully all hydrogens, that means that they probably have a double bond somewhere. And let me show you on the board real quick. Actually, I don't want to do that. I want to do it up here. So that way you can see it on the recording. You'll use a different equation, okay, when they're unsaturated, because you have a double or a triple bond. All right. When they have double bonds, at least one double bond, you're going to use this thing that looks like this. That's going to be your equation. When there's triple bonds, you're going to use this equation like this. Okay? So single, looks like that. Double looks like that. And triple looks like that. Now let me split this with this. And let's kind of quickly, don't want to do too much today. Let's talk a little bit about single bonded naming. I'm going to guess that everybody's probably heard the prefix pent. Like a pentangle or a hexagram or maybe an octopus, maybe a decade. So 5, 6, maybe heptane, maybe heptangle. Maybe what's that? Yeah, you've at least heard a few of them, right? Oct, dec, hex, pent. Probably never heard of prefix meth, eth, prop, or bute. Maybe just from, looks like butt, doesn't it? But it's bute. Um, Methane, ethane, propane. So you're going to have to memorize these 10. I'm not going to go past 10. Okay. So on these, all you do is you just count the number of carbons that there are. Okay. And since they're single bonded, they're called alkanes. This is the basics. All right. It's going to get more complicated. So make sure you understand this part of the naming. When you have a certain number of carbons and a certain number of hydrogens, all you have to do is figure out, are they single bonded, double bonded, or triple bonded? And if they're single bonded, the ending is ANE. Then all you got to do is count the number of carbons. So it's methane. If there's two, and you're like, well, how do you know if it's single or double? All right, well, here's my equation up here. I just got to do a little ciphering, a little mathematics, and just say, okay, 2 times 2 is 4 plus 2 is 6. Yes, that works. This must be a hydrocarbon that's fully saturated. So I'm going to end it with ane, and it's 2 of them. So it's ethane. You can do the reverse. Look at your ending. It's an ane, which means that they're all single bonded. So you're going to use this equation. This tells you that there's 3 of them, because over here is my handy dandy little thing. So it's propane, C3H. 3 times 2 is 6 plus 2 is 8. I got just enough time. You guys name these. And we'll practice both. Figure out the chemical equation, the chemical formula, and the name, or vice versa. Okay, so give me the number of hydrogens here, the number of hydrogens here. Give me a chemical formula here. Give me the name here, and give me the name here. Give it a try. That's a lot. Okay. I know for some of you, it might have been, got it, no problem. For some of you might want to, I recorded this entire hour. Okay. So you might want to go back through and rewatch it